So now today we do perfectly inelastic collision. हमने इलास्टिक किया, पार्शली इलास्टिक भी किया. अब हम करेंगे परफेक्टली इनलास्टिक कॉलिजन, और ये सब अभी हम कर रहे हैं वन डायमेंशन में. परफेक्टली इनलास्टिक हेड ऑन कॉलिजन. हेड ऑन कॉलिजन, हेड ऑन का मतलब मैंने समझाया था कि if the particle is moving in some direction after collision, before collision direction remains same, then it is called head on collision. Or we also said collision in one dimension. Here what happens, one particle m1, if it is moving with the velocity u1, another particle m2, if it is moving with the velocity u2. Always I keep the vector sign, because it's not, it may be like that m2 is not going towards right, m2 is coming towards left, or m1 is going towards left. So in this case, if the directions are towards right, you take that velocity as positive. If any direction is towards left, then that direction we take as negative. So it totally depends upon the sign, because it's a vector quantity. Let's suppose after some time they collide. They collide like this. This is m1 and this is m2. And after collision, they don't separate from each other. That means they get stuck with each other. Now they are moving together with some velocity. That means now m1, m2 will have same velocity v. So this collision is called as perfectly inelastic collision. So we can say that after collision, both particles stick with each other and become one system. Stick with each other. So what will remain, or in other words, you can say that they are not getting separated from each other. So we can say that velocity of separation is zero. Velocity of separation is zero. Separation is zero. And you know the formula of coefficient of restitution is actually velocity of separation, divided by velocity of approach. But यहाँ पे तो velocity of separation is zero है. That means 0 by something will be 0. So in perfectly inelastic collision, basically E value is 0. That also you remember. What we will equation we can use here. So we know in any type of collision, the total linear momentum always remains conserved. Total linear momentum of system, individually it can change, but for a system it always remains conserved. So what equation we can use? We can use m1 u1 plus m2 u2, that is the total momentum before collision, is equal to, now I'll take m1 plus m2 together because they are moving together. So their momentum also will take, and they both are moving with the velocity v. So if I ask what is the velocity v here, so I can say m1 u1 plus m2 u2 divided by m1 plus m2. This, what is the velocity? This velocity is called common velocity after collision. Common velocity after collision. समझ में आया नील?
Yes, sir. Just 1 second.
ओके, आपने मुझे वो वर्क एनर्जी पावर वाला नहीं भेजा था ना? ठीक है,
Yeah,
मैं
sir.
आपको वो स्टडी बुक मटेरियल बुक भेजने वाले थे ना मुझे, जो आपका बुक है वर्क एनर्जी पावर का।
हाँ हाँ हाँ,
बट
वो
आप,
वो वो आज खत्म करके मैं भेजता हूँ।
ठीक है ठीक है।
Yes.
Okay, now as I said that in this process, in any kind of inelastic collision, it may be perfectly inelastic or partially inelastic, kinetic energy is not conserved. Total kinetic energy is not conserved. Total kinetic energy, there is a loss of kinetic energy. If I try to find that expression, that what is that loss? Sorry, loss in kinetic energy. Loss, always we can write that loss is basically initial kinetic energy minus final kinetic energy. This example only will take. So initially m1 was moving with the speed u1, m2 was moving with the speed u2. So I can say my loss of kinetic energy is initial energy, that is half m1 u1 is square plus half m2 u2 square. Now this is the initial kinetic energy. Final kinetic energy, both particles are moving with the common velocity v, that is equal to m1 u1 plus m2 u2 by m1 plus m. That is half mass. I'll take now, I'll add the masses m1 plus m2 into v square. V I'll put. This is the final kinetic energy. So if I subtract initial minus final, I get the kinetic energy loss. Half I am taking as common here. So this becomes m1 u1 is square plus m2 u2 square minus, this is here m1 plus m2, and then v square. V I have this m1 u1. So it may be m1 u1 plus m2 u2 square divided by this denominator also we have to do square m1 plus m2 square. This and this gets cancelled. So I can say it is 1 half m1 u1 square plus m2 u2 square minus. We can take the square of this. So this is m1 square u1 square plus m2 square u2 square plus 2 m1 m2 u1 u2, and this whole divided by 1 m1 plus m2 is also there. Now if I subtract it by just using the common LCM m1 plus m2, so I can write here 1 by 2. m1 plus m2 is the LCM. And then m1 plus m2 I have to multiply with the first term. First term if you multiply, you get here m1 square u1 square. m1 I have multiplied. Now m2 I'll multiply to the first term, that is m1 m2 u1 square. Now the second m2 u2 square I multiply with both, so it becomes here m2 m1 u2 square, and m2 if you multiply it becomes m2 square u2 square. Now minus is there, so sign will be changed here. I will write first m1 square u1 square. This is also minus plus minus minus m2 square u2 square, and it becomes here minus 2 m1 m2 u1 u. If you check here, then this m1 square u1 square it gets cancelled here, and m2 square u2 square also gets cancelled. So you will be left with m1 m2 u1 square plus m1 m2 u2 square minus 2 m1 m2 u1 u2, and this whole divided by m1 plus m. So you can write here, I can take m1 m2 common. So let's take m1 m2 common, and down I can write m1 plus m2, and I have here u1 square plus u2 square minus 2 u1 u2, that is a square plus b square minus 2ab. That means the loss in kinetic energy formula is half m1 m2 divided by m1 plus m2, and this I can write as u1 minus u2 square. That is the loss in kinetic energy in perfectly inelastic collision. Understood, Neil?
Yes, sir, understood.
Okay, please write it.
Yes, sir, done. Yes, sir, done.
Okay. So this is about perfectly inelastic polish. I'll take one example on this. Let's suppose one particle of 2 kg is moving with speed 4 meter per second. Another particle of mass 3 kg is moving with the velocity 2 meter per second. If I say if they collide, inelastically, inelastically, then they may ask two questions. What is the common velocity? What is the common velocity after collision? And second, they can ask, what is the loss in kinetic energy? What is the loss in kinetic. So we use our formula that we have derived. Velocity common formula is m1 u1 plus m2 u2 divided by m1 plus m. Here both are moving in same direction towards right, so we'll take the velocity as positive. M1 is 2, this is 4, plus M2 is 3, plus T is 2, divided by this is 2 plus 3. It means 8 plus 6. 8 plus 6, that is 14, divided by 5. That means it is 2.8 meter per second. That is the answer of the first question. Second, they ask in this process the kinetic energy loss. So kinetic energy loss also I'll use directly the formula. If you forget the formula, then you can go by the basic process, find the initial kinetic energy, and then subtract the final kinetic energy. But if I remember the formula, that will be easy for me in the NEET examination. So it is M1 M2 by M1 plus M2, and this is U1 velocity of larger velocity minus smaller velocity. So M1 is given as M1 is given as 2 and M2 is given as 3. So 2 into 3 divided by 2 plus 3, and the velocity difference is 4 minus 2. So I can say this is 4 minus 2 square. So this will be 1 half 6 by 5, and this is 4, 2 square. So that is 3. So answer is here 12 by 5 joule. You can say that 2.4 joule is the loss of kinetic energy. Okay, Neil.
Okay, sir. Yes, sir, done.
Okay. One example I am giving you this on this. Please try to solve. Let's suppose I have a 4 kg particle and it is going with the speed of 3 meter per second. And I have a 6 kg particle which is coming is with velocity 2 meter per second. And my question is this, Neil, that if they collide inelastically, inelastically, then find 2 points you have to find. First, their common velocity, common velocity, and second thing, the loss in kinetic energy. You try, Neil. Okay.
Okay, sir. Sure.
Yeah.
Yes, sir.
Okay, what is your answer?
For common velocity, it is 2.4 meters per second.
Okay,
For loss and kinetic energy, 1.2 joules.
1.2 joules.
Yes.
Okay. What was the common velocity, Neil, that you have got?
2.4 meter per second.
Okay. If you check properly, the common velocity formula, you have written this m1 u1 plus m2 u2 divided by m1
M1
plus.
plus M2.
Are you using this formula?
Yes, sir. I'm using this formula.
Okay, so 4 multiplied by 3 plus
Plus 6 times 2
6 multiplied by minus 2 nil. You know why
minus.
minus?
Acha, in the opposite direction, sir.
Yes, that you have missed, I think. So this is 12 minus 12. The common velocity answer is 0. Okay.
Okay.
And as far as loss of kinetic energy is concerned, the formula was half m1 m2 divided by m1 plus m2, and that is u1 minus u2 square. One velocity is 3, other is 2. So I can say this is 1 half. Mass is 4, 6. So 4 times 6 divided by 4 plus 6. U1 was 3. U1 is 3. And U2 is minus 2. U2 is minus 2 square. So this becomes 1 by 2. 6 times 4 is 24. By this is 10. And it becomes minus minus plus. So 3 plus 2 square. So 1 half times 24 by 10 plus 5 square is 25. So this is here 12 to 5 times to 6 times. This is 5. 5 into 6. Answer is 30 joule. If you understood, then please do the correction.
Okay, sir.
Today,
Hmm.
today we'll have two classes. Okay, 1 hour I am taking right now. 1 hour I'll take at night. Okay, that's okay for you.
Yes, sir. Sure.
9:30 I'll take one more class. 9:30 p.m. Okay.
Okay. Will. We'll send the books till then, sir. PDF of the
हाँ,
book till then.
या वो भेज दोगे तो उससे कुछ क्वेश्चन हम लोग कर लेंगे ना, इंपॉर्टेंट क्वेश्चन सॉल्व कर लेंगे, ठीक है।
हाँ सर, हाँ सर, हाँ सर, हो
ये
गया ये।
ओके, नाउ all we have discussed collision in one dimension. Few examples will concepts will be discussed with collision in two dimensions also. That is called oblique collision. हालांकि नीट में बहुत ज्यादा टू डायमेंशन नहीं पूछते, वन डायमेंशन ही पूछते हैं, बट फॉर नॉलेज के लिए, थोड़ा रेफरेंस के लिए जानना जरूरी है। फर्स्ट, इलास्टिक collision, oblique elastic collision, or we can say that elastic collision. Elastic collision in two dimensions. In two dimension, elastic collision in two dimensions. If I take one example, let's suppose I have m1 and it is moving with the velocity u1. This is m2 and it is also moving with the velocity u. Always remember u1, u2, always I write in vector. If direction is opposite, you take the negative. After collision, what happens? Right now they are moving in this line only. They are moving in this line. But after collision, what happens that m1 goes in this direction. This is the m1 goes with velocity v1, and m2 might go in this direction. This is m2 is going in this direction with the velocity v2. With their initial direction of motion, this angle is maybe given as alpha and this angle is given as beta. Like when you play carom, then carom, when you hit from the striker, then that bits can go in this direction and striker can go in this direction. So that is an example, that elastic collision in two dimensions. You are hitting in a straight line only, or you might also have hit some at some angle also, that also we do. So this is called oblique collision. As the collision is elastic, so you will have always two equations. One equation is conservation of momentum. So from conservation of linear momentum, conservation of linear momentum, first equation. Now momentum is of, here you see this here, it has momentum initial is along x-axis only, m1 u1, and it has a momentum also along x-axis, that is m2 u2. This I am taking as the x-axis, and this vertical line I am taking as the y-axis. So now final momentum has two components. Along x-axis, here you can see the component will be m1 v1 cos alpha, because that angle is alpha, and along y-axis it should be m1 v1 sine alpha. Here m2 v2, this angle is beta, so m2 v2 component will be here along x-axis m2 v2 cos beta, and sine will be down here, it will be m2 v2 sine beta. So first we'll conserve the momentum along x-axis. Here, that is the difference here. Here you have to conserve the momentum along both axes, along x-axis and then y-axis. So initially the complete momentum was along x only. So I'll write m1 u1 plus m2 u2. And here along x-axis we have m1 v1 cos alpha प्लस m2 v2 cos बीटा। ये जो है ये आपको पहला ये लिखना पड़ेगा, पहला आप मोमेंटम कंजर्व करना पड़ेगा। आप मोमेंटम y के अलोंग, मैंने यहाँ पे ऑलरेडी डायरेक्शन लिख दिया है अलोंग x एक्सिस, इसलिए मैंने फिर से वेक्टर साइन नहीं दिया है। नाउ अगेन आई एम स्पेसिफाइंग द डायरेक्शन दैट अलोंग y एक्सिस। So y axis initially there was no momentum, so initial momentum will be zero, but final momentum is there. One is upward, other is downward. Upward I'll take positive, downward I'll take negative. So upward I can say m1 v1 sine alpha minus this is m2 v2 sine beta। तो ये सेकेंड इक्वेशन हो गया जो आपको यूज करना चाहिए। And now we can also conserve the kinetic energy because it is an elastic collision. So from conservation of kinetic energy, now kinetic energy में कोई component लेने का जरूरत नहीं है क्योंकि that is not a vector quantity, that is a scalar quantity. So only you can write the initial kinetic energy, that is half m1 u1 square plus half m2 u2 square, and the final should be simply half m1 v1 square plus half m2 v2 square। सो आप ये दो यूज करके मोमेंटम को दोनों एक्सिस के अलॉन्ग यूज करना है और काइनेटिक एनर्जी को एक ही बार यूज करना है बिकॉज इट इज स्केलर क्वांटिटी। यू कैन सॉल्व द क्वेश्चन। अंडरस्टूड नील?
Yes, sir, understood.
या
Yes, sir. Done.
Okay. So this is perfectly elastic collision in two dimension. If I write perfectly inelastic, perfectly inelastic collision in two dimensions. तो ये भी आसान है, जैसे let's suppose a particle of m1 is going with the velocity u1 and another particle m2 is coming in this direction with the velocity u2, and let's suppose they are colliding here. इनके बीच में यहाँ पे कॉलिजन हो जाता है, ऐसे कॉलिजन हो, और ये कॉलिजन परफेक्टली इनलास्टिक है, मींस कॉलिजन के बाद दोनों आपस में एक साथ मूव करते हैं, एक दोनों अलग नहीं होते, सेपरेट नहीं होते. In that they both get stick with each other. This is m1 and this is, and they move, let's suppose they either move karte hain with some velocity v. So if they ask what is v, in which direction it is moving, uh, यहाँ पे भी हम एक्सिस जो है ऐसे ही रखेंगे. This I'll keep as x-axis and this I'll keep as y-axis. This x-axis, this is y-axis. So what is the velocity or what is the angle, at what angle with the x-axis they will move after collision? अगर ऐसा कुछ पूछते हैं वो, so we know the formula, velocity v is equal to formula I am going to use m1 u1 plus m2 u2 divided by this is m1 plus m. Now the if you check the direction here properly, then you see that m2 was coming down and coming down along y-axis. So its velocity is along y-axis and going down, whereas m1 is going along x-axis and going towards positive x-axis. It means that if I try to use in vector form, so I can say that v will be m1 u1, I can use I cap because it is towards x-axis positive, whereas m2 I have to use u2 minus j cap because it is going down the y-axis, and that is m1 plus. So I can say that it is m1 u1 divided by m1 plus m2 I cap minus m2 u2 divided by, separately I am writing now because one is along x-axis, other is along y-axis. So that is the way to write the common velocity after collision. If they say what is the loss in kinetic energy, so kinetic energy is scalar quantity, so no need, no change here in direction, if whatever direction it will remain same, and that you can use always kinetic energy initial minus kinetic energy final. So initial was half m1 u1 square plus half m2 u2 square, and final if we have already found the velocity, common velocity, then we can directly put here and solve. No need to remember long formulas, only you have to understand the concept. It's clear?
Yes. Yes, sir.
Okay.
Yes, sir, done.
ठीक है। ठीक है, कॉलेजन हमने कंप्लीट किया। इस पे क्वेश्चंस आप भेजो, फिर हम उसमें से क्वेश्चंस करेंगे, ठीक है।
हाँ, हाँ,
ओके, आज शाम को 9:30 में क्लास रखते हैं।
yes, okay,
बाय।
okay.